So, imagine for a second, what if instead of just writing code, you could actually build the tools that create the code? Well, today we're going to dig into a really cool tool called Tiger that lets developers do exactly that. It's a totally different way of thinking about how we build software.
Okay, so to really get what Tiger's all about, we have to start with compilers. Let's use an analogy here. Think of a master chef. You hand them a recipe, right? That's your source code. The chef takes that recipe, follows all the steps, and whips up an amazing meal. That's your final application, ready to go. Basically, every programming language has its own master chef, turning our text instructions into real software.
But what if you didn't want to just follow someone else's recipe? What if you wanted to build the entire kitchen from the ground up? A workshop where you could invent totally new kinds of chefs, each with their own unique style. And that is the giant leap Tiger lets developers make. You go from being the cook to being the kitchen designer.
But wanting to do something that big, well, it brings us to a huge problem that has been bugging software developers for a long time. We'll call it the builder's dilemma.
Here's the core of the problem. How in the world do you build a system that can generate native machine code? We're talking about the raw, lightning-fast instructions that a computer's processor understands directly. And building the tools to create that? That has always been an incredibly specialized and, frankly, painfully complex process.
And I mean, just look at the difference here. On the left, you've got the old way. It's this whole mess of heavy-duty tools you have to juggle. You need a C++ compiler, another separate tool called a linker, and you have to have this deep, expert knowledge of these massive frameworks like LLVM. It's a huge pain. But the Tiger way? Look at the right. The entire process gets simplified down to a single line of code. It's just mind-blowing.
And let's be real about that traditional juggling act. You'd be wrestling with some of the most notoriously complicated parts of C++. You're trying to bolt together all these different tools that were never really meant to work together, all while managing this tangled web of dependencies. The learning curve is just so incredibly steep that it's kept this kind of power out of reach for most developers.
So how do we fix this dilemma? How do we make this power accessible? Well, this is where a completely new approach comes into the picture. Enter Tiger.
So this is it. Tiger is what's known as a compiler infrastructure, and it lives entirely inside the Delphi programming environment. What it lets you do is build actual Windows applications programmatically. And what that means is you're writing code that writes other code. Instead of just feeding it a text file, you're actually constructing the program, piece by piece, using a special set of commands.
And this right here is the absolute most revolutionary part. How many other tools or libraries or dependencies do you need to pull this off? Zero. That's right, absolutely none. It is completely self-contained, which, in this world, is an absolute game changer.
This is that whole kitchen-in-a-box idea we were talking about. The entire assembly line, from sketching out the blueprint of your code, to optimizing it, to linking it all together into a final runnable file, all of it happens right inside your own application's memory. No external tools are ever needed. It's all in one place. All right, so you've got this amazing, self-contained code kitchen. What can you actually build with it? This is where things get really creative.
Yeah, let's go back to our cooking analogy for a second. If Tiger gives you the ultimate state-of-the-art kitchen, what kind of amazing new dishes can you invent? Turns out, the menu is pretty much wide open.
Well, for starters, you could literally invent your very own programming language from scratch. Since Tiger handles all the hard, back-end stuff, you get to focus on the fun part, the language design itself. Or let's say your app uses scripts. You could compile those scripts directly into machine code, making them run at blazing fast native speed instead of being interpreted slowly, one line at a time.
And it doesn't stop there. This opens up huge doors for game development, letting you compile game logic for maximum performance. You could even build an application that generates its own plugins on the fly. And for anyone wanting to learn how compilers actually work, this is an incredible teaching tool. You can learn the fundamentals in a friendly language like Object Pascal instead of having to fight with arcane C++.
Okay, so what are these special ingredients? What's going on under the hood that makes all of this possible?
The process of actually using Tiger is super clear and logical. It's just a four-step workflow. First, you create the main compiler object. Second, you configure your target, like, say, an executable file. Third, you define all your types and functions. And finally, step 4, you just tell it to build. That's it.
And one of the most elegant things about it is what's called a fluent API.
All that really means is that the code you write to build your program, it reads almost like a natural sentence. You can chain commands together one after another, which makes the whole process clean, readable, and so much easier to follow than typical compiler code. Tiger also gives you this really rich set of building blocks for all your data. You've got records that work just like C structs. You have arrays, you have Pascal-style sets, and you get full control over pointers. This gives you all the fine-grained control you need to talk directly to the operating system or any other low-level code.
But maybe, just maybe, the most powerful secret ingredient in this whole kitchen is the optimizer. Tiger has this really sophisticated optimizer that works in multiple passes. You can think of it like the master chef's secret technique for refining a dish. It automatically makes your final application smaller, cleaner, and much, much faster.
And we're not just talking about a simple cleanup here. This thing performs some really advanced optimizations. For example, dead code elimination finds and literally removes parts of your program that can never be reached. It's like a great editor cutting out useless sentences. It does all this smart stuff to make sure the final result is as lean and mean as possible.
So when you put it all together, what you realize is that Tiger isn't just another library. It's really a tool for empowerment. It gives Delphi developers the power to create things that were just out of reach before. Brand new languages, high-performance engines, the next generation of software tools, all from the comfort of an environment they already know and love.
Which, of course, leaves us with one final thought. When you have a tool that strips away all that complexity and puts this much creative power in your hands, the only real limit is your imagination. So, if you could create a brand new programming language, perfectly designed for one specific thing, what would you build?